Hi, my name is Lakshat, and I've been building a text editor for writers. Now, the why will come a bit later. First, let's go over what I have been building. So, we can write in different formats. Like, one can write poems, one can write blogs, one can write essays. I specifically myself write short stories, and I'm also working on a novel. Now, I have realized is that uh, there is not a singular text editor which support all these types of writing. Like we need to struggle with formatting and other stuff ourselves. So my text editor will support multiple formats such as poems, essays, short stories, novella, novels, books, blogs, research papers, etc. Now let's just go over one category to just show you like what different things exist. Now let's just go with poems. Poems can be of many types. Like if someone is a poet, he writes poems. Poems can be of many types. Like I write haiku, but many people also write lyrical poems. Many people also write ballads or mythical poems, like which are narrative, like Ulysses or Odyssey. Now there is a new category of poems too that is blank. Same goes with the short stories. If we look at short stories, and all these categories have with their subsections where there is a different type of complexity, different type of world building, different type of requirements. Now, I only am familiar with these formats, or I have worked with these formats before. But there may be someone who wants to write plays, who wants to write a drama, who wants to write a film scripts. So my text editor should also be extensible. So a feature of it would be it is extensible too. Now, many people like myself write in English, but there exist many writers who write in Hindi. There are many writers who write in Urdu or in their own local or regional language. So my text editor should also support multilingual. So if I someday change my mind, I should be able to write, in other languages too. And the last part would be ease of use. If I add this much complexity, or if my text editor is too much complex to use, or there are too many features, so I would get distracted, or I won't be able to learn, or somebody who's using my text editor won't be able to use it efficiently. Now, for that, I have introduced Zen mode, where Zen is a Buddhist term for focus and all. Let's not go into those details. But Zen mode would just mask out all the features, extra features, and just give you a blank space where you can write in flow. Then the next part that I required myself was character maps. Like when I'm writing like the novel that I'm working on, the characters have complex dynamics between them, which change with time. So I wanted a visual representative of those characters, their stats, their relationship with each other. My text editor will have character maps. It will also have a inbuilt geography, like uh, what are the distance measures and what are the transportation mediums, what resources are there extra. Then there would be economics or world building, to be honest, like geography, economics, and other stuff which comes into world building, like if I create a magic system and all. Now, after that, I also need a plot line, like how it all progresses with time. What is my time scale and all that. I have not seen any text editor that implements all these features. There are a few open source alternatives like Campfire, but they also just focus on world building stuff. They don't provide you with an editor that also handles that part. Now, I also have some ambitious plan for my own text editor. If I'm able to implement all this, I'll also implement a world AI module where if I had done a good enough world building, then my characters will be able to unfold a story by themselves without me intervening. Then there is personalized cloud improvement models. Those are for myself that I write and I'm bad at communication. So I should be able to improve my language, my grammar, the sentence structures with my own personalization. So that's for future reference. Then plot hole detection. Like if my story has a glaring plot holes that I have ignored because I'm biased about my story. That will be an ambitious plan. Then readability stats, like if it, someone can read your story or not, like how is your language. There already is some platforms, but they're paid. So yeah, that's it. That's what I have been building. Okay, so let's talk about the why part. The why did I build my own text editor? In a single sentence, that would be that my handwriting is bad and I mostly write on my computer and I require those character mapping and all. Before now or previously, I used to map my characters like this, the script, the connections and all. So, what better way to do it than using technology? There are already some text editors that I use by many writers, many and endorsed by many famous writers or very good writers that I look up to. First one is Google Docs and Microsoft Word. Now, both of these are very good in text formatting and all that stuff, but they do not have character maps. They do not have a world building part. They do not have a plot line or timeline feature. So I know they can be extended. Like we can use some workarounds to extend those features, extend these editors and all, but they crash too. Now there is Obsidian, which gives us graphical mapping and all. Actually, the graphical mapping part came from Obsidian itself. Like I could map my characters and all that, and create my world, create different sections in that. That came from Obsidian. Now Obsidian can be extended, but I wanted to build something on my own. Like it also uses just my Markdown format, and I do not always write in Markdown format. So let's move on to the next one, which is Scrivener. Now this one is paid. This one has good file structure and uh, good character mapping. No, it doesn't have character mapping, but it has a note section. But it is paid. Then we have Campfire. This is used by many. This is paid. This is used by many, and this helps many writers to create their own world. It helps in world building, but it does not have its own editor capabilities. And it is a platform where you can read and write. It is a mixture of both, and it does not have a plotline feature either. And we come to the manuscript. This one is very great. It's been built in Python and it's been used by many. It has a plotline feature, but it does not have a character mapping feature. Now, one might ask, why not just build plugins for all these? And my answer would be like I want to know how text editors actually work. So, what better way to what better way to learn than building a text editor myself? Now, I've been building my own text editor in Rust. You might ask, why Rust? Well, I've been learning Rust for the past 1.5 year. And I've also built some medium level projects in Rust. I've read the Rust book, but I wanted to work on you know, a large project which I could scale and, give to the community back. So that's why I chose Rust. And because it's low level, it handles memory very sleekly. It was a new concept for me and it was very exciting. So I did not know how to build a large project. Like previously, I built those medium level projects. My senior advised me not to jumble everything into one file. Like I did not used to do any modular structuring of any of my code. So taking his advice, I wanted to build this text editor in a formal way. At least start this project in a formal way. Okay, so now we are at the problem of how do we implement a text editor? Let's go by first principles. If I gave you a blank screen, how would you implement a text editor? Ultimately, it all boils down to two things. How do we give an input? And how do we take that input and display it, the output part? Now, what we ultimately want to do is, like if we think about it, we press a key on our keyboard, we capture it, then we display it on our screen. Now, it could be a terminal screen, it could be a graphical user interface. I have mostly worked with a terminal user interface. Now, let me just map the flow that we have just written. We have a keystroke from a keyboard. It goes to an application where it is captured. Then it is stored into a buffer. We can just say a buffer, and then it goes to display, display output. Now, this is the flow that we already know. Like, if this happens, now this is a text editor, kind of like if we press uh, something on keyboard, it gets displayed. Now, I've I've built my text editor in terminal primarily because I'm much more experienced in terminals and how they work underneath the surface. Terminals use something called as ANSI sequences. You can think of them as signals. Like there is an ANSI sequence for clearing your screen when you type in clear in your terminal or your shell. It clears your screen. Ultimately, it all boils down to an ANSI sequence, which the terminal understands and then clears your screen. We won't go into much detail about ANSI sequence. You can study about them yourselves. Now we know how we can make our cursor move, how we can hide our cursor, how we can clear our screen, how we can change the text colors and all. That is all done through ANSI sequences. Now we could build, we could just map up these ANSI sequences with our own, input capturer here, and then we could just display with some ANSI sequence here. We could store it into a file or some buffer. But remember, I told you that this project will be built formally. So I went ahead and scoured for some tutorials on how to build a text editor. And I found many great resources. There is a Kilo text editor, very great tutorial, but it is in C. Thankfully, I got uh, Hecto. Hecto is a tutorial for building a basic, simple text editor. It is by Mr. Philip Flanker. It's by Mr. Philip Flanker. It is a very great tutorial. It teaches you how to the internals of an editor, of a text editor, how to do cursor movement and all that. I followed his tutorial to build a basic version of my text editor. Now let's go into the details of how we did and what we did. Now, let me first introduce terminals to you. The terminals, you can think of terminals in two layers. The first one is a terminal emulator, then the second one is shell. Different operating systems have different terminal emulators and different shells. Like the Windows uses the Windows terminal have a PowerShell and CMD command prompt. The macOS terminals has ZSH shell underneath the surface, and the GNOME terminal for Linux has Bash under the hood. Now, let's see this question. Can we write directly to every terminal? The answer is not always. Not always. Because different operating systems have different environment, different sequences. Like the historically, Windows has used its own API for its console, but and Linux has used ANSI. Now the modern terminals give much more support for the ANSI escape sequences, but there are still many quirks which cannot be handled by just ANSI sequences. So we have two solutions with us to tackle this problem. Either we can go ahead and build an abstraction for each terminal to take in the input, Or we could use a library. I have used a library named crossterm, which takes away that job from me. Like I do not have to build abstractions for each terminal. So crossterm handled it for me. It handles keystrokes, it handles events, it handles rendering too. But we will get into that later. Crossterm was introduced in the tutorial. The perks of following a tutorial. If I was building it myself and not taking any help, I would have maybe just written abstraction for Linux, Mac OS, and Windows. Okay, so we have an answer that we can use crossterm to uh, write directly to every terminal. Now, I would like to pose another question. What happens when you type in to the terminal? Like if I just press the key A, it goes there into terminal, but it is not rendered just at that moment. Like if I see the command echo and here is A. When I type this A, only when I press enter, only when I press enter, this A will be given back to the screen. Only then will be this A will display on the screen. What happens actually is the terminal takes whatever we type. That's in normal mode. In normal mode, terminal stores whatever we type into a buffer. And when we press enter, it echoes back into the program. Or you can say it displays, like if we are keeping the flow easy, it display. Now, when we are building a text editor, we want when we type A, the screen should show A. If it does not, then it is not a text editor. Like if we type A, then we have to press enter every time to display it on screen. Then it would be much harder to write anything. So let me introduce to raw mode. Like this was normal mode. Then comes raw mode. Here we handle the keystrokes ourselves. The terminal does not add terminal doesn't add it into its own buffer. We handle every keystroke. Now this raw mode functionality was also given to us by crossterm. We just abstracted those function, enable raw mode and disable raw mode. Like I built an abstraction on top of that. Did not directly call these functions. So when we are in raw mode, let me just map out what the flow looks like and how we capture the keystroke. So now let's discuss how do we capture keystrokes. Let's discuss the flow. First, we input from our keyboard. It goes to the OS. OS is a process to which captures it. It's an IO device. It goes to the OS, and OS handles our IO devices. Then it goes to our terminal. Terminal goes to the underlying shell. Shell is a program too. There is a process that is running. The process goes to our process that is crossterm handler, which handles the events. Then it sends the value to our editor to handle. Now the editor has the value. Now let me just discuss something first. Crossterm library gives us some structured events for normal keyboard strokes. Then it gives us handling for control commands, alternate commands, tab, and special characters extra. It also gives us an abstraction for mouse handling and all. But I would like to pose a question here. What about custom events? Like, what if we want something to happen when the editor received this data? That is an event too. I know we can handle it with custom logic and all, but how do we hook into this event? Like we, like an external plugin, how does it hooks into it? This event that the editor has received the buffer. Now, I will handle this part further down the video. That will be very interesting. But now, what about displaying results? Our editor has the value. It sends it to the terminal abstraction. Now, I could just directly write the cross terms own abstraction, or I could just use the Rust own flush function. But I used the cross term abstraction of Q, which Q is the handling. I could also use the write macro, but I use this Q because it is much more elegant. Now then it goes to terminal emulator, then it displays it on screen. So that is our basic flow. Now the next part that I am going to be discussing is very important and very interesting part. Please stay for that. Okay, so let me pose a question first. We typed the word hello. We are trying to move our cursor. Let's not go into that implementation details now. Let's just assume that we are trying to move the cursor from the end to the beginning. We press the left keystroke. How much should our cursor move? You will say, what a silly question. It should move one character, one O. It should be at second last position now. But let me ask you this fundamental question. What is a character? Let's see. A character can be anything. A 5, a Hindi literal, a Urdu literal, a Russian literal. So how are they represented in a computer? Like a computer does not understand the symbols that we use. A computer understands only ones and zeros, bits. So let's take it easy and uh, slowly understand how are these characters actually represented in memory in different languages and in different encoding techniques or different ways. First, let's see in C. We are defining a character C equals to A. In C, a character is of 1 byte, which is 8 bits. Now, this A is C has been traditionally using ASCII encoding. So, if you want to learn more about ASCII, I'll link that, and any other link, I'll just put that into the description. You can check them out. ASCII will convert it into a number. This number will now represent A. Computer does not understand this number either. Computer only understands zeros and ones. So this number represented in binary will be this. Fair enough. But you see, we only have how many bits here? 1, 2, 3, 4, 5, 6, 7, 8. 255 values, 0 to 255. ASCII can only encode 128 values. The other values are reserved for some other purposes. You say only 128 characters. So ASCII only supports English that much. Well enough. What about Hindi? What if I want to write something in Hindi? Or what if I want to write something in some another language? What if I want to write an emoji? ASCII will break. It won't work because, it only has some limited amount of numbers. Okay, so let's take a breather. What about Rust? We can define characters in Rust like this, and it will work. Just keep sure you are using these single quotes instead of double quotes because Rust is weird like that. So character in Rust is a Unicode scalar value. What is a Unicode scalar value? We will talk about it after this. Now, by using this Unicode scalar value, which is of 4 bytes ultimately, which is 32 bits, and that the computer understands. Now, Rust characters will be able to support emojis, different languages, Hindi, English, Urdu, Arabic, Chinese. But does it solve our issue? Like, have we really defined what a character is? Let's see. Let's take it slowly. Let's see what Unicode scalar value is. Then I'll pose the final question and we'll show you some interesting problem that we are encountering in our own text data. Okay, so let's understand Unicode. Unicode is just a universal mapping of characters to a Unicode code point. Now, it is of 4 bytes and it is universal. It has many values. Now, computer does not understand this, the Unicode for code point. The computer does not understand this. Computer only understands bits. So, to convert this Unicode code point into bits, we use encoding techniques. We have three major type of encoding techniques that are used. First one is UTF-32, where we just take the full Unicode code point, turn it into a 4 byte memory and 4 bytes bits, 32 bits, and just send it to the memory. Simple enough. But it also wastes space. Like if the character is only if it's a ASCII character, it does not need all the 4 bytes. It will on it can work in 1 by 2. So we reach at UTF-16 where usually it will store the value in 2 bytes because not all values need all the 4 bytes, but sometimes it has to use the 4 bytes. It makes the handling complex and all, so it is not much used. Now we reach at UTF-8, which is majorly used because it is backward compatible with ASCII. For ASCII, it will just store a 1 byte value. For European languages, 2, Asian languages, 3 bytes, and emojis, 4 bytes. Now, about this UTF-8, because it is backward compatible with ASCII, it is universal. But Rust behaves a bit weirder than if you are normally putting things into strings and not using these codes. If you are interested in that, you can just read the article. I'll just put that into my description. Now, I, let me pose a question. How many characters are there in this? Let's see. So, how many characters in this? If you say one, it's wrong. This consists of two separate characters, E and this character. These are both different multiple Unicode scalar values. Now, we have a problem with our definition because the user sees one character, this, and we know, or our editor internally knows that it is not just one character, it represents two characters. Even in Rust, it is two characters because Unicode scalar values. So, how do we actually traverse the text? By which unit? If you know how loops work, like if I write a simple loop of int I equals to 0 to int I equals to 1, then we traverse or move forward by the value of an int, a basic int. How do we traverse our text now? This is a problem. So now let's solve it by first principles again. So what does a user actually sees? He sees a character like this. How do we identify that this is one character? How do we traverse it? Now there are some rules by the Unicode Association. They have also implemented a simple structure known as a grapheme cluster. What it represents is this, the thing that is perceived by the user. So we can traverse from this to this point with now just a single arrow. by using the rules defined by those organizations. Now, using those rules, we could implement them ourselves too. But why? Why should we rebuild the cycle again? So we use a well-maintained library of Unicode segmentation. Unicode segmentation. What it does is it gives us the boundaries of these graphemes. Like if they exist in text, they give us back like this is from where the user perception starts, this is where it ends. So treat is as one character for traversal. Like if I want to delete this character, treat it as one. If I want to move left to it, treat it as one character. If I want to move right, treat it as one character. That is done by Unicode segmentation. But there is another issue that we have not talked about. Like for normal characters, we have 4 byte characters, right? Like it is 4 bytes. But for this, we have 8 bytes. Now, there are many hybrid types like these. There are multiple emojis which are hybrid, which are combination of multiple Unicode scalar values. How do we know which value represents what? Because terminal is not pixel based, terminal is column based. So let's assume for this 4 bytes we define one column. What about this one? We define 2 columns, but how do we know that it is 8 bytes? Again, we could use the rules, or we could just directly use the library that is well maintained, which is Unicode width. These both are available in the Rust crate that we have used primarily in our code. Now, this is just a theory part. Next, I'll discuss the implementation that we have done, that I have done in my own text editor. So, in my code, I defined a text fragment which will represent each visible character. It will have a grapheme, the visible bit of how it looks. It is a string. Then it will have a byte offset. Now let's look at it with an example. If I write, see, if I write this, I know this is 1 byte. I know this is 2 bytes. I know this is 1 byte. I know this is 1 byte. While traversing this one, I need to uh, know where I need to go next. So each graphing will store where it is starting. It will store where it is starting. It will store it where it is starting. It will store it where it is starting. So it is the relation with the actual bytes and what is being represented. Now, the next thing is about display width. See, it is one character for the user, but it represents 2 columns here. Let's look at it with an emoji. If I write HE, a laughing emoji, LLO, this is 4. It occupies some columns. It is rendered as in only one column, but it itself represents 4 columns. Let's assume. So when we are skipping, when we are traversing, when we are moving our cursor, we will move these columns, 4 columns. The last one is replacement character. There are many characters which are not visible, like there is NUL, there is BEL, and many more like this. So if we are not able to handle any character, we will just replace it with this. That's it. Now let's discuss flow. First, keyboard, we stroke it. It gets converted into UTF-8 bytes. Oh, I misplaced the explanation for this a bit. Like you see, it is UTF-8. Unicode scalar. It is 1 byte. What about this one? It will have the full 4 bytes in UTF-8. So we need to know how much we need to travel from this 1 byte, and from like this 1 byte, how much we travel, this 1 byte, how much we travel. So we are storing the starting byte index, so we are able to traverse easily. So keyboard, it gets converted into UTF-8 bytes, which are just Unicode scalar values. We use Unicode segmentation to find where are the grapheme clusters actually. When we find the grapheme clusters, we find its Unicode widths, like how wide they are, how they need to be represented, how are they to be traversed. Then I stored them into my text fragments, and then we move towards cursor movement, editing, and rendering. Now, I have not explained this part, cursor movement, editing, and rendering. I'm not giving a tutorial. If you want to follow the tutorial, you can go to the Hector one. I'm just giving the explanation of the hard problems that I encountered and the interesting bits. At this point, I would like to thank the Polaris Fellowship team for shortlisting me for the round three. Thank you for your consideration. Uh, this concludes my the core idea and logic and the principle behind the project that I'm pursuing. This was the first major problem that I encountered while building this text editor. It has also made the editor multilingual, if you have noticed. So, uh, thank you once again for your time and consideration and for watching till now. Thank you.